Collision-free protocols. Although collisions do not occur with the CSMA CD once the station has captured the channel, they can still occur during the contention period. These collisions adversely affect the system performance, especially when the bandwidth delay product is large, such as when the cable is long and the frames are too short. Not only do collisions reduce the bandwidth, but they make the time to send the frame variable, which is not a good fit for a real-time traffic such as a voice over IP. CSMA CD is also not universally applicable. There are some protocols that resolve the contention for the channel without collisions at all, not even during the contention period. Most of these protocols are not currently used in major systems. However, in a rapidly changing field, having some protocols with excellent properties available for future systems is often a good thing. In the protocols to be described, we assume that there are exactly n stations, each programmed with a unique address from 0 to n minus 1. It does not matter that some stations may be inactive part of the time, because we also assume that the propagation delay is negligible. In our first collision-free protocol, the basic bitmap shows that each contention period consists of exactly n slots. If station 0 have a frame to be sent, it transmits 1 bit during the slot 0. No other stations is allowed to transmit during the slot. Regardless of what station 0 does, station 1 gets the opportunity to transmit 1 bit during slot 1 only, but only if it had frame queued. Generally, station J may announce it has a frame to be sent by inserting 1 bit into slot J. After all n slot have passed by, each station has the complete knowledge of which station wishes to transmit. At that point, they begin transmitting frames in numerical order. Since everyone agrees on who goes next, there will never be any kind of collisions. After the last ready station has transmitted its frame, an event all stations can easily monitor, another n-bit concentration has begun. If a station becomes ready just after bit slot has passed by, it is out of luck and must remain silent until every station had the chance, and the bitmap will start all over again. Now, if we have low load, then we can calculate the efficiency by dividing d over d plus n. Now, when having a high load, we can conclude that n is the contention period propagated over n frames, yielding that the overhead is only 1 bit per frame. With that being said, the efficiency can be calculated by d over d plus 1, and that is when we're having a high load. It's only good for a high load. Now, when it comes to calculating the wait time, it will be the sum of the time it queues in the station plus n minus 1 times d plus n. Now, protocols like this that desire to transmit a broadcast before the actual transmission are called reservation protocols. And the reason so, because they reserve the actual channel in advance in order to prevent the collisions. Now, in order to explain it briefly, we can start from this angle right here. So we have 8 collision slots. As you can see, they're numbered from 0 to 7. And here we can clearly see that only station 1, 3, and 7 are ready to be transmitted. Therefore, they send their frames, gap 1, 3, and 7. Now, when another bit starts, we have... there we go. We have a new contingent plan starts, and as you can see here, we have 1 and 5 that are ready now. So we send 1 and 5. And then a new bitmap starts, and as you can see here, it only has 2 that is ready, so 2 is sent.